Today we are going to review the algebra concept of systems of equations. So I can solve systems by substitution and elimination. All right, so solving systems by substitution. Here are the steps. We want to first make sure that we have one equation that has a variable isolated by itself. Sometimes that means you may need to rearrange an equation to make it say x equals or y equals. But we have to have one variable by itself in order to get started with substitution. Next, we'll then substitute the equation with the isolated variable into the other equation. By substituting it into the other, we now should be solving for a variable where we only have one variable in the entire equation. So you start off with variables of x and y, but by substituting it in, you'll know you do it correctly if you only have then all x's or all y's in a single equation for you to then solve for that variable. Once you've solved for that variable, you'll substitute that value from step number 3 into one of your original equations to find the other variable. I would suggest that you substitute it into the equation that is isolated, that has one variable isolated by itself. So because we're dealing with two variables, our final answer needs to be written as an ordered pair where it's in parentheses, otherwise it's not an ordered pair, and x goes first in an ordered pair followed by y. All right, so let's look at an example using those steps to solve by substitution. We've got two equations here. We've got y equals negative 3x plus 11 and negative x minus 6y equals 2. So like it mentions, in order to do substitution, you need to have a variable isolated by itself. And the nice thing about this problem is that that already occurs in the top equation. We have y equals. So that means I'm going to take what y equals and substitute it into the y in the bottom equation. So I get to keep that negative x as it is. I get to keep minus 6, but now in parentheses, I'm substituting in y as negative 3x plus 11. I need to finish the rest of that equation. It equals 2. So notice that I know I substituted it incorrectly because everything in that equation now only contains the variable of x. So now I can start solving for x. I'll keep the negative x. Now be careful, I got to get rid of the parentheses, so I'm going to distribute, but I have to distribute everything that's out in front, so that would be a negative 6. So negative 6 times negative 3x would give us a positive 18x. Negative 6 times 11 is going to give us negative 66. That still equals 2. We've got some like terms. Negative x plus 18x is going to give us 17x. We'll still have minus 66 equals 2. I'm going to add the 66 over to the other side. That gives us 17x equals now 68. And then I'm going to divide both sides by 17. And I get x to be 4. Now, remember, that's not my final answer. I don't stop there. My final answer needs to be an ordered pair. Well, we just found out that x is 4, so that goes first. Now I need to find the y. I need the second half of my ordered pair. So I have to now substitute the 4 back into one of these equations. But like I mentioned, it'd probably be fastest if we go back to the equation where that variable is isolated. So y equals negative 3 times 4 plus 11. So now I can start solving for y, which is what I want. Negative 3 times 4 is negative 12. And when I add 11 onto it, I get the value for y to be negative 1. So 4, negative 1 would be my solution. Let's take a look at another example. We've got to solve by substitution. We have 3x minus 2y equals negative 11. And x minus 8y equals negative 11. As you can see in this example, we do not start off with a variable isolated by itself. I don't see x equals, I don't see y equals. So now it's a matter of, okay, well, I have to do some rearranging. What variable should I be getting by itself? If I look at the top equation, there's a 3 with that first x, and there's a -2 with that y. If I look at the bottom, there's technically a 1 with that x, and there's a -8 with that y. When you're trying to determine which variable to solve for, having that +1 in front is going to be your best bet to get a nice variable by itself. So I'm actually going to take this bottom equation of x minus 8y equals -11, and I'm going to rearrange this to get the x by itself. So that means I have to add the 8y over to the other side. And so now I have x equals, and it doesn't matter which one of those numbers you put first, but they are not like terms, so I cannot combine them. But I know that x equals 8y minus 11. So now I have this variable by itself. That top equation, we haven't done anything to it yet. I'm just going to rewrite it exactly how it is down here below, because then now I can just focus on this system. And so because I now know that x equals an 8y minus 11, I can substitute that into the x in the bottom equation. So we'll have 3, but then in parentheses, I substitute in what the x value is. And now I have to finish the rest of the equation. So minus 2y equals -11. Every single thing in this equation now only contains the variable y, so that's a good thing. So I'm going to start distributing to get rid of the parentheses. We'll have 24y minus 33 minus 2y equals -11. Combine my y's, we'll have 22y minus 33 equals -11. I'll add 33 to both sides. That gives us 22y equaling 22. And then I'll divide both sides by 22 to find out that y equals 1. Once again, that's not my final answer. I can't just stop there. My final answer should be an ordered pair. Because we found y first, we found the second number in our ordered pair. We now need to go back and solve for x. So now that I know that y equals 1, I'm going to go back over here on the far left to the equation where x is isolated by itself. X equals 8 times y, which is 1, minus 11. Well, 8 times 1 is 8. When I subtract 11, I'm going to get x to equal -3. So that's our first number. So our solution is -3, 1. All right. Sorry, my pen is not working again. Okay. So now let's solve by elimination. So here's our second type of solving. So to eliminate a variable, the two equations must have the same coefficient with the same variable, but must also have opposite signs. Okay, so that means that we want to line up our like terms. We want x's one on top of the other, the y's one on top of the other, the equal signs on top of the other, the numbers on top of each other. But in order to eliminate, we have to have opposites, meaning like the x. I could have a 2x, but then I would need a -2x as well, because a +2 and a -2 would then be opposite. So that means that if you don't already see opposites, sometimes we must multiply one or both equations in order to obtain coefficients that have opposite signs. Once we have that, we'll add the two equations together. By adding the equations, the variables that have opposites should eliminate, so we should no longer see that. And then that means we'll have one variable left over that we can solve for. We'll then have to take the answer that we get from step number 2 and substitute it back into one of our original equations to solve for the other variable. Because once again, your final answer should be an ordered pair of x comma y in parentheses. So let's take a look at this example. We've got 8x plus 3y equals 2 and -16x plus 6y equals negative 28. The like terms are already lined up nicely for us. Notice how the x's are lined up, the y's are lined up, the equal signs are lined up, the numbers are lined up. But if I look at the x's, I've got an 8 and a negative 16. Those are not opposites because they're not the same number but opposite signs. If I look at the y's, one's a 3 and one's a 6. Not opposites. So unfortunately for us, we cannot just add up our equations right away. We have to get opposites. So the nice thing that I see about this is that with the x's, one of the x's is positive and one of them is negative. So we're already kind of halfway there. Because 8 is smaller than 16, if I can somehow turn 8 into 16, then we will definitely have opposites. 8 is a multiple of 16. If I multiply by 2, I'll get that positive 16, which then would be opposite of negative 16. I just have to make sure that I multiply that 2 by everything in that top equation. So my new top equation, when I multiply everything by 2, I get 16x plus 6y equals 4. The bottom equation didn't have to get multiplied. It stays as it is. But now because I have negative 16 and positive 16 in front of those x's, I have opposites. I can add up these equations. The x's will disappear, and then I can start solving for y. So the x's go away. That turns to 0, so I don't have to write them. 6y plus 6y is going to give us 12y. And 4 plus a negative 28 is going to give us negative 24. So then the last step to solve for y is to divide both sides by 12, and we get y to be negative 2. Once again, I'm going to write it as an ordered pair for my final answer. Y is second in my ordered pair. So now I have to then solve for x. So I'm going to go back to one of the original equations. It doesn't really matter which one of those equations we go back to. So because I need to solve for x, if I look, because my original top equation had a positive 8x and the bottom has a negative 16x, I usually tend to go towards the positive numbers. So then that way we don't potentially lose anything based off the negative. So I'm actually going to go back to the original top equation. It's 8x plus 3, but now I get to replace that y with negative 2, and that equals 2. And now we have an equation where we can solve for x. So 8x, this turns into a negative 6. I'll have to add the 6 over to the other side. That gives us 8x equaling 8. So when I divide by 8, we get x to be positive 1. So our solution is 1, negative 2. Okay, let's take a look at another example. We're going to solve by elimination. We've got negative 4x minus 7y equals 12. We have negative 3x plus 4y equals 9. All of our like terms are lined up nicely, but if I look, the x's do not have opposites. One's negative 4 and one's negative 3. We're not going to be able to add them and have it disappear. Same thing with the y's. We've got a negative 7 and a positive 4. So unfortunately, those will not add up to 0 to have it eliminate. So now we have to try to figure out what do I need to multiply in order to get opposites. If I look at the x's, 3 is smaller than 4, but I can't multiply 3 times something to get 4. If I look at the y's, 4 is smaller than 7. 4, if I multiply something by a 4, I'm unfortunately not going to get 7. So this is the case where I'm going to have to multiply not one, but both equations by something. It doesn't matter which variable you try to eliminate first. For me, I see that the y's are already opposite signs. The 7 is negative, the 4 is positive. So it's not that I have to worry about changing any signs. It's just the numbers that are going to have to change. So I'm going to do the y's. So my thought then is, what's the first number that 4 and 7 have in common? And so if I'm thinking about multiples of 4, it's like 4, and it's 8, and it's 12, and it's 16, and it's 20, and I can keep going. If I think about all the multiples of 7, it'd be 7 and 14 and 21. The first time that they're both going to have something in common is when you get to the number 28. So how do I multiply 7 to get 28? Well, I have to multiply by 4. And I'm going to keep it a positive 4 because then when I multiply, I'll have a negative 28 on the top. The bottom equation, since I need to turn that 4 into 28, means I need to multiply the bottom equation by 7. And I'm going to keep that one positive because then once again, I'll have one number on the top that's a negative and one number on the bottom, which is positive, and they'll be able to add to 0. So then once again, I just have to make sure that I distribute that 4 to everything in the top equation. Negative 4x times 4 would be negative 16x. Negative 7y times 4 gives us negative 28y. That equals 12 times 4, which is 48. Then I have to distribute the 7 to everything in the bottom equation. Negative 3x times 7 is negative 21x. 4y times 7 gives us a positive 28y. And 9 times 7 is going to give us 63. Now I can add these two together because once again, the y's are opposite. They are going to disappear. So if I start combining the x's, negative 16 plus a negative 21 is going to give us a negative 37x. The y's cancel out. 48 plus 63 is going to give us 111. I'm going to divide by negative 37. And that gives us a value of x to be negative 3. So once again, that's not my final answer. It needs to be an ordered pair. In an ordered pair, x goes first. So now we just have to figure out the y. I'm going to go back to one of my original equations. If I have to solve for y, it looks like the bottom equation might be fastest just because, once again, I like to go back towards the variables that are already positive. So I'm going to have 3 times negative 3, because that was what x is, plus 4 times y equals 9. Negative 3 times negative 3 is positive 9. I'm going to then subtract 9 over to the other side. That gives us 4y equals 0. I have to divide both sides by 4, but 0 divided by anything is 0. So y is 0, so my solution is negative 3, 0. Oops. And so that's us solving systems by both substitution and elimination.